Hi, welcome to another 4AC learning video. In this video, we want to look at example 3.9b, which is found in your lecture notes. 3.9b shows a circuit as follows, with two sources, one a voltage source, the other one a current source. And the question reads as follows. For the circuit shown above, we are given Vs is 50 angle 30 degrees volt, Is is 10 angle 0 degree ampere, whereas Z1, impedance 1, is 30 plus J 40 ohms, and impedance Z2 is 30 angle minus 90 degrees, and impedance Z3 is 30 angle 45 degrees. Okay, so these are all the information given to us. What we are asked to do is to, number one, find the current I1, I2, and I3. Current I1, I2, and I3 in polar form. And we are asked to calculate the power delivered from the voltage source Vs and the power delivered from the Is, or the current source. Okay, let's see how we can answer this question. Well, to answer this question, we need to make use of Kirchhoff voltage law. Kirchhoff voltage law. Right, if you were to recall, Kirchhoff voltage law basically says that for a circuit, the voltage, the sum total voltage around a loop, for example in this case loop 1, Vs should be equals to V1 plus, in this case, V3, and we can give this as V2, right? So if I were to write it out, I will have voltage source Vs is equals to V1 plus V3, right? And if I have to use Kirchhoff current law and look at this particular node, okay, maybe I call this node A, the sum total of the current coming into or going out of this node must be equals to 0. So from here I can see I1 and I2 coming in, whereas I3 is leaving the node. So if I were to write it, I will have I3 is equals to I1 plus I2. Now because I2 is basically in the same path as Is, so Is is actually, rather I2 is actually Is. So I can just write it as I1 plus Is. Now, for the voltage source, I can replace this with I1 Z1 plus I3 Z3. Now, between these two equations, if I call this equation 1 and this is equation 2, I can substitute equation 2 into 1 so that I have an equation which is only with the only unknown I1. I do I3 later. So this is what I will do. Then in other words, substitute equation 2 into equation 1. That will give me Vs equals to I1 Z1 plus, instead of I3, I will substitute as I1 plus Is multiplied by Z3. rearrange this. Since I1 is the one I want, I will get I1 Z1 plus Z3 plus IS times Z3. Again, I rearrange this. I will have I1 on this side, Z1 plus Z3 equals to Vs minus Is Z3. So here I have everything I know except I1, so I can now find I1. Substitute Z1. We are given Z1 is 30 plus J40. 30 plus J40 plus Z3. Z3 is given as 30 angle 45. Equals to Vs. Vs given as 50 angle 30. Angle 30 minus Is is 10 angle 0 ampere multiplied by Z3, which was 30 angle 45. So from this, on the left, I can get 50 angle 30 degrees minus 300 angle 0 plus 45, so it's 45 degrees. On my left, 30, if I were to convert this to rectangular form, 30 45 degree would be 30 45 degrees gives me 21.21 plus J 21.21. So put that inside here. I will have I1 30 and 21, so it's 51 21 40 and 21 plus J 61 and 21 equals to, now this I need to expand it out for rectangular, so I will have 50 angle 30 minus 10, so it's 300. So I will have 43.3 plus J 25, which is 50 angle 30 minus 212.3 plus J 212.3, since it's 45 degrees. So that gives me minus 169 minus J 187.3 on this side. So I need to convert this to polar. Both sides I need to convert to polar. So what I do is, since I need to divide, okay, this one rectangular, here is multiply, I move it over, it becomes divide. At the same time, I convert it to polar. Same thing for this, I convert this to polar. That gives me 252.27 angle minus 132.06 degree. So I can write this down here, 252.27 angle minus 132.06 degree. Okay, and this side I convert to polar. I have 79 0.81 angle 50.08 degrees. So I1 will be 3.16 angle minus 182.14 degrees in ampere. Very small current. Okay, that's to calculate I1. Now I know I1, I can then go back to my equation 2 to determine my I3. Right, I can use that to find I3 now. Okay, so how do I find I3? From equation 3. Equation 3, I3 is equals to I1 plus IS. I1 I know is 3.16 angle minus 182.14 degrees, and IS is given to me earlier as 10 angle 0. Convert this to rectangular form so that I can determine the values. So that's 3.16 negative, so I have minus, almost close, because it's very close to 180 degrees, so it's 16 plus J 0.12, that's I1, plus, because here is 0, so it's 10 only, so here I have 6.84 J 0.12. So I3 is just 6.84 angle about 1.0 degree ampere. So I have I1, which is 3.16 ampere, I3 6.84, I2 is the same as IS, which is 10 ampere. So the next part will be, okay, this is my part 1. So my part 2 is to calculate the power from contributed by Vs. Now power contributed by Vs can be given as a formula: Vs, the voltage, multiplied by the current contributed, which is I1, cosine of the angle of Vs minus the angle of I1. Right, that will give me Vs is 50 volts, I1 is 3.16, the cosine, the angle 30 degrees minus, minus 182.14 degrees. So that gives me 133.79 watt. Remember, in phasor form, voltage is 30 degrees and current is way behind. Current is the other way, I. So this is a lagging power, you can say that, right? So there's 133.79 watts, whereas power from I source is given by the formula Pi source is equals to now V source, we need one extra calculation, because if we were to look at the circuit, the voltage, or the so-called equivalent voltage, is actually from here to here. V. If I call this VS, oh, VS will be the same. So let's call it VA, right? So VA, I need to calculate it first. So VA times IS, cosine of the angle of VA minus the angle of IS. Okay, formula is given like that. So I need to calculate VA. Now what is VA? VA is just V2 minus V3. Sorry, the other way. Minus A2 IZ. Oh, sorry, bro. Okay. So that gives me IS or I2 Z2 plus I3 Z3. So it's tan angle 30 degrees multiplied by 30 angle minus 90 degrees plus 6.84 angle 1 degree multiplied by 30 angle 40 degrees, 45 degrees. So working this out will give me 208.66 angle minus 46.91 degrees volt. So I can use this number into my calculation. So I will have 208.66 multiplied by IS, which is 10 cosine of the angle minus 46.91, which is from there, minus 0 degrees. So that gives me a power of 1425.38 watts. Now this time the voltage is the one that is lagging. The voltage is minus 46.91 degree, whereas the current IS is at 0. So IS is, so this one is a leading power. It's a little bit different from the other one. Okay, so that's all the calculation for this example 3.9b. I hope you learned something from here. Thank you. Bye bye.